Chapter 4 is on what are called rational functions. And of course, rational means what? Fraction, ratio, that's right. So my functions are going to look like this. F of x is going to be a fraction. Okay? And you're going to have P of x, some polynomial up top, and you're going to have Q of x, some polynomial down there in the denominator. So this is a natural place to go after Chapter 3. You study polynomials. We know we can add polynomials, subtract polynomials, multiply polynomials. If you do that, you just get another polynomial. But if you divide polynomials, well, I'm not sure what you get all the time. Actually, we've done a lot of division, haven't we? What kind of division have we done? Synthetic division, right? We kept dividing by a certain polynomial we called x minus c. Well, now we're going to be dividing by other things, too. Okay? So, to understand these, I like what the book does, and you'll read tonight, and some of you already read part of Section 1, and you'll be getting into it. But I want to start with something even more basic than what the book does about rational functions, okay? So we're going to think about the function y equals 1 over x. That's the function I want to actually sketch a graph of. So we're going to sketch a graph of y equals 1 over x. I think that's a good starting place. Okay. By the way, when we go ahead to do the homework for this Chapter 4, Section 1, the first thing they're going to ask me to do is something we've done before. Find the domain. Actually, let me call it f of x. F of x is 1 over x. So I'll say find the domain. Well, what would you tell me is the domain of f? Yeah, we always ask, what can it not be, right? And it can't be what? 0. So the domain of f, you'd say like, well, from negative infinity to 0, and also from 0 to infinity, but we're not allowed to equal 0, right? In general, okay, here if I just put this back up about general rational functions, what's the rule? The rule is that q of x is not allowed to equal what? 0. Right? And so this is how I find the domain. I just make sure that I ask myself, well, whatever that bottom polynomial is, it's not allowed to equal 0. So in this example, that's about as easy as it gets. The bottom polynomial is x. Okay. But I want to go ahead and sketch some graphs, some inputs and outputs. So let's make a little chart here maybe. We'll list x and f of x, okay? Give me a nice input, please. 2 is a great one. So is 1. I can't use 0, right? Output would be 1. When I input 2, what's the output? 1/2. So here's 1 comma 1. Here's 2 comma 1/2. Another nice input. What? Negative 1 is a nice one. I'm allowed to do negatives. I could do negative 1 or negative 2, and then I get negative 1 or negative 1/2. So I'm going to see some symmetry, won't I? What if I put in something larger, like 4? What's my output? 1 over 4. I would say that this function is increasing or decreasing. Like even if I put in something like 6, I'm getting to 1/6. It's always decreasing, isn't it? As I move from left to right. But what else can I say about it? Yeah, you're not going to have any x-intercepts, are you? What if you put in something really large, like 100? 1 over 100, right? I'm really close to what? I'm really close to the x-axis, okay? And that has a name. Do you guys know the name of this thing? We say here that the x-axis is what's called an asymptote. Asymptote. An asymptote is, by definition, a line that the function approaches. And again, this approaches, well, that's kind of an intuitive understanding, but I think it's good enough for what we're doing, for our purposes. The function approaches that line. You know, in the past, we have talked about end behavior. We talked about end behavior of polynomials. Here, end behavior is going to be different. Because how did I do end behavior? What I used to do is I used to say, as x goes to infinity, f of x. Do you remember what I used to put here as my answer? There were only two possibilities when we did polynomials. What were the two possibilities? Positive infinity or negative infinity. Well, what happens in the function 1 over x as x approaches infinity? Well, because it has an asymptote, a horizontal asymptote, f of x is actually going to approach what? 0. The output gets closer and closer to 0 as the input gets bigger and bigger. For example, if I put in 1,000, my output is 1 over 1,000. Do you guys see that? Who's with me so far? Good. By the way, what would happen if I put in negative 1,000? The only difference is, right, you would have negative 1 over 1,000. And so the only difference is that when you go this direction, yeah, it approaches 0, but it's approaching from the bottom. Okay? So let me write that down. As x approaches infinity, we have f of x approaching 0 also. And your authors, they make a distinction here. You're going to see this in the answers. You're going to see, well, f of x approaches 0 from the top. We're going to put a little plus sign there. Or f of x approaches 0 from where? The bottom. Yes, thank you. As x approaches negative infinity, f of x approaches 0 from the bottom. Thanks, Dan. So that little sign means from the bottom. Or from the top. So the end behavior is going to be different than what we saw for polynomials. Now, there's a couple more inputs that are worth mentioning. Let me show you. X and f of x. Let me throw in 1/2 in for x. Now, what's my output then? Okay. Or 1/4 for x. What's my output? 1 over 1/4 would be 4, right? 1 divided by a fraction means take the reciprocal. You guys look a little blank here, I'm sorry. Let me try throwing in 1/3. What's the output? Okay. How about 1 over 100? What's that mean? It means that this curve, it goes through 2 comma 1/2. It goes through 4 comma 1/4, but then, do you know what that is? Well, remember, we know we're not allowed to put in what value? 0. But you know what we have at x equals 0? I'm going to put a little dotted line here because this is a vertical asymptote. The curve gets closer and closer to the line. Okay? It approaches the line. So y equals 1 over x has a horizontal asymptote, and it also has a vertical asymptote. Okay? We could say, let's see if this makes sense to you. As x approaches 0, I'm going to put a little plus sign. What's that mean? As x approaches 0 from the positive side, from the right, f of x is going to approach. Can you tell me what it's going to approach? Well, it just gets bigger and bigger. So we're going to say it goes to infinity. This is not end behavior. This is just kind of separate. What would I say about this? As x approaches 0 from the negative side, what happens to f of x? It approaches negative infinity. It's going to decrease without bound. Okay? So there's a graph of f of x equals 1 over x. To me, if you understand that, you understand quite a bit. Okay? What's that? No, I wouldn't call that end behavior. I would call that, this is a vertical asymptote, what we're noticing here. But what we're noticing here, this end behavior, when you actually equal some constant, this is my horizontal asymptote. And it is end behavior, right? Because when we say end behavior means x is going to infinity or x is going to negative infinity. What happens when x gets really, really big? But what I'm saying for these functions is that there's going to be other numbers that we have to think about what happens to because we have these vertical asymptotes. All right. To me, this is a great place to start because now I can ask you about a different function. G of x is 1 over x plus 2. That is slightly more complicated than f of x. But I bet you, because I saw those exam redos, and I know you guys understand Chapter 1, Section 7, I bet you know what the graph looks like. Do you? It's shifted. That's right. Is this a shift on the input or the output of the function? Well, this is a shift on the input of the function. Even though I don't have parentheses, you guys understand that there's really parentheses around the denominator of a fraction, parentheses around the numerator of a fraction. So what kind of shift is this? Which direction? To the left, right? Horizontal. How far? 2. It's the exact same graph shifted to the left. Well, what does that mean? Well, it means a couple of things. First of all, what's the domain? What are you not allowed to equal? So it goes from negative infinity to negative 2 in union with negative 2 to infinity. What do you think I'm going to have at x equals negative 2? You're right. What's it called? That's right. It's a vertical asymptote. Well, I could do the input-output to show you if you want. But matter of fact, I'm going to do one input. G of x, can you give me what the y-intercept would be? What does that mean? Yeah, where does it hit the y-axis? How do I figure that out? So I could compute G of 0, right? That's 1 over 0 plus 2. What's that? 1/2. So it goes through 0, 1/2. I could check that it also goes through negative 1, 1. It's the same exact graph, It was just shifted to the left. This is the power of what we did in chapter 1. We spent so much time on it. I don't need to do a whole new graph for G. I know it's exactly the same thing, shifted to the left. We did a shift. And this is the x and y. These are both real now, okay? Stay away from imaginary. This is the x-axis and the y-axis, right? But it's the same graph. And so I think that's pretty cool. Does this have a horizontal asymptote? Sure it does, right? It does. Okay. Beautiful. We're done for today. That's enough to get started. Look at what... Hey guys, in number 1, see how the degrees are the same? You see that? You know what we're going to have a horizontal asymptote. Now, do you know what the horizontal asymptote would be? It's going to be y equals, any idea? It's a good guess. What happens if I put in 1,000? What's the numerator? 1,000. What's the denominator? About what? 3,000. You know what the horizontal asymptote is going to be? 1/3. Right. 1,000 over 3,000. You could take the coefficients of the highest degree term, and that ratio will give it to me. Here, let's try number 2. Number 2 has a horizontal asymptote. Any idea what it's going to be? It's not 3/5. They're trying to trick you. -7 over 2. Because if you put in 1,000, you have -7,000 over, or you have 7,000 over -2,000. Are you guys with me? Okay. Now, what about something like number 4? Well, number 4, this is what Delaney was just asking. What happens if the degree in the denominator is larger? Well, then, that's kind of like my 1 over x situation, where because think about what if I put in 1,000 for number 7. I'd get 4,000 in the numerator, but what would I be dividing by? 1,000,000. 4,000 divided by 1,000,000 is very close to 0. It's very small. So if the degree of the denominator is bigger, my horizontal asymptote is 0. Okay? And this is all in the book. You'll see the examples will help you with this too. But the thing I wanted to do before we left was just factor this. Let me factor it. So I'll take out an x, and I have x squared plus 2x plus 1. And it'd be really nice if I could factor that denominator. X times x, I think it works if you do -2 and plus 1. Okay? So this is x times x plus 1 times x plus 1 over x minus 2 times x plus 1. Okay? Now, where do I get a vertical asymptote? We're going to get a vertical asymptote at x equals 2. Is that clear to people? Because it makes what 0? The denominator 0. But it doesn't make the numerator 0. Okay? But I'm going to tell you that we get a hole in the graph where? At x equals -1. Why is that one not an asymptote? Because it would make both of them 0. Okay? And we are out of time. But I think what you saw is probably enough to